For problem number 6, I want to just remind you that when you see 5 minus 7 times something, that does not mean that you're allowed to combine the 5 and the negative 7 to make negative 2. What we want to do is get rid of that kind of floating number out there, that 5, get rid of the 5, move it to the right side by subtracting 5 from both sides. So doing that, we get negative 7 times the absolute value of 1 plus 4x is greater than or equal to negative 77. And then dividing both sides by negative 7. Careful, we just divided both sides of an inequality by a negative number. We get 1 plus 4x in the bars. We have to switch the direction of the inequality symbol. 77 divided by 7 is 11. Both negatives. Negative divided by negative is a positive. So now we have a compound inequality in which we can rewrite. In other words, we're going to sandwich the 1 plus 4x, sandwich the stuff between 11 and negative 11. So therefore, we're going to get x by itself by subtracting 1 from all three parts. And doing that, we get negative 12 less than or equal to 4x, which is less than or equal to 10. And then, because I'm running out of space, I'm going to skip showing that step of dividing both sides by 4. So we are dividing both sides by 4, and we're going to get negative 12 divided by 4 is negative 3, less than or equal to x, less than or equal to 10 divided by 4 is the same as 5 divided by 2, 5 halves. So we have our inequality notation. Now we need to write it using a graph. So we're going to graph all the real numbers between negative 3 and 5 halves. And 5 halves is 2.5, so it's a positive number. Just write 5 halves. That's okay. And we want to include both negative 3 and 5 halves and show the solution being all real numbers between negative 3 and 5 halves.